All right, find the linear approximation for this function x cubed minus x squared plus x plus 1 at 1 comma 2, and use that linear approximation to approximate the value at 1.1. Okay, that's the question. Now, how does that work? Remember, the linear approximation is basically an approximation of the function f by a line using the derivative as the slope of the tangent line, right? So what we are asked to do is to do this kind of thing, right? Trying to find the value of the function at 1.1. Now, of course, you can plug in 1.1 here and get the answer, but that's not what it says. Many times you don't have this explicit function. All you have is the value of f1 and the derivative, and you can try to estimate what f of 1.1 is by linear approximation. The slope is an essential feature of this, right? So you have to find the slope of the tangent line at 1. Oh, by the way, is this even a good question? Does it make sense? Well, let's just check. F of 1 had better be 2, because that's the only way to to do this problem. If you have to find a linear approximation of this function at 1 comma 2, that implies that f of 1 has got to be 2. Well, f of 1 is 1 cubed minus 1 squared plus 1 plus 1. And that is, of course, 2. So it checks. This point is 1.2, or 1 comma 2. Let's take the derivative now. It's 3x squared minus 2x plus 1. If you evaluate this at 1, because that's the x value at which we are asking this question, that's 3 minus 2 plus 1, and that's 2. And this is the slope of the tangent line, this tangent line right here, right? And so at this point, you can do this in a couple of ways. One, if you want to use the formula, the line, which is the linear approximation, which is really the line, the equation of this tangent line is y minus 2 is equal to m, which is 2, times x minus 1. So this gives us a very nice linear function, 2x minus 2 plus 2. That's 2x, period. Okay, so it turns out this is the linear approximation of f close to x equals 1, which we also call this the linearization of f at 1. So then you plug in 1.1, and that's going to be 2.2. This is an approximate value of f of 1.1. Okay, or you can estimate. Remember, f of 1 is equal to 2, right? And in this case, this point is only 0.1 away from this. So dx is actually 0.1 away. That's this picture here. You have, this is dx, this is dy, this is dx, this is dy, and the real value, the real difference is what we call delta y. But you can approximate it. So f of 1.1 is approximately 2 plus, remember the derivative, also maybe I should write this. This is f prime of 1 times dx. That's called the differential. Maybe I should rewrite this. This is f of 1, the y value at the source point. Okay, so that's 2 plus, then the question is, what's this dy? Well, that's 2. That 2 comes from this one here. And then dx is 0.1. And so that's 2 plus 0.2, and that's 2.2. So same answer here. An approximate value of f of 1.1 is 2.2. Okay, so that's number 5. Let's go to number 6 of this exercise. Practice test. Number 6 says the volume of the sphere is given as 4/3 pi r cubed. If a spherical ball of dry ice is evaporating, the volume is decreasing at the rate of 8 pi cubic inches. So what is 8 pi cubic inches per second, per minute? Right, that is the volume, right? This is evaporating. The volume is decreasing at the rate of, so dv dt is that. Okay. How fast is the radius decreasing when r is equal to 2? So find dr dt when r, the radius is 2 inches. Okay, so any related rates problem starts with this. You firstly have the equation that tells you how one quantity is related to the other, and then you take the derivative with respect to time. dv dt is equal to, and then you do 4/3 times 3 pi r square, remember, because r cubed becomes 3r square. And then using the chain rule, because r is also a function of time, you add at the end, well, you multiply this whole thing by dr dt. Now, this is what we need to find. This is what we have, okay? So, but let's close this out. Okay, so we can also say, well, dv dt pi 8 pi is equal to 4 pi r square times dr dt. Okay, so dr dt is 8 pi divided by 4 pi r square. You can cancel this. Pi can cancel. This is 2 r square. Okay, so when r is equal to 2, dr dt is 2/2 squared, which is 1/2. Oh, 1/2. So 1/2 what? 1/2 inch per minute. Remember, V was expressed in terms of cubic inches, right, per minute. So this will be inches per minute. Okay, not too bad, right? This is pretty simple, right? Okay, number 7, 25-foot ladder. Ever famous calculus problem in related rates. The ladder, the sliding ladder problem. It's 25 feet. Okay, is leaning against the wall, and the bottom of the ladder is sliding away at 1 second per 1 foot per second. How fast is the top of the ladder decreasing? Let's call this y and let's call this x. All right. So what do we have? X squared plus y squared is equal to 25 squared. Okay, that's just the Pythagorean theorem. We are told that dx dt is, this is the rate at which x is increasing, and that's 1 foot per second. Now with that, we are supposed to find dy dt. Well, again, we differentiate everything here with respect to time t. So 2x times dx dt is equal, plus 2y dy dt is equal to, now this is 25 squared, but it's still a constant. You take the derivative of a constant, you just get that. And in fact, you can cancel everything by 2. And so this is what you get, right? Okay, so we're looking for dy dt. dy dt, let's just say y dy dt is equal to negative x dx dt. So dy dt is equal to negative x over y dx dt. Now we know what dx dt is, okay? That's 1. So this will be negative x over y. That's very simple. All right, what does the question say? When the top of the ladder is 20 feet above the ground. So when the top of the ladder, which is, y is 20 feet above the ground, okay. Oh yeah, so when that happens, what's x? Well, x is the square root of 25 square plus minus 20 square. You can think of that, and you can calculate this, or you can use the Pythagorean theorem, and try to reduce this. So if you have 25, and if this is 20, this is similar to 5, 4, right? And so this part has to be 3. It's just a multiplying by 5, of course. So it has to be 15. Okay, so the ratio 15, 20, 25 is the same as 3, 4, 5 for the famous Pythagorean triplet, right? So in other words, 3, 4, 5 would create a right triangle. And because of the similarity, 15, 20, 25 would also do that. So x is 15 at this point. So dy dx then, sorry, dy dt is negative 15 over 20, which is negative 3 over 4 feet per second. And that is the speed at which y is decreasing because, you know, y, you have a negative sign here. Okay, so that's number 7. Again, these problems aren't supposed to be too difficult, and I hope you are finding this not too bad at this point. Okay, so now we will go to number 8 in the next segment.